Hello and welcome to the first session of Looksies. It's Byron speaking, and in Looksies we're going to look at something, which today will be a little Unix utility that scratches an itch. So what is it? It's actually called nth, and it's a little experiment of someone who wanted to learn Rust. And he explained why not to use cart. And basically what it does is it splits columns by white space of input lines, which is quite useful, especially if you have stuff like, word count, for instance, or whatever, whenever you want to just select one column. Or maybe ls. LSL probably has plenty of columns too. Like this. Yeah, that's a wonderful application for columns where nth could be used. So let's try to use it. Let's grab it and do something with it. So we clone it first. Cargo build. Let's just run it. Let's run it right away. That will of course build it first. Oh, regex. I think regex is not even used there anymore, but let's have a look. Source nth.rs, I think it was called. Yeah, I'm really fast and hacky here. So in a way, the beauty about this program is that it's so short. And oh, look at that. It doesn't use 2 spaces per tab, but I shall be fine with that. So let's see how it works. I think that's the first thing. Did it run? It did run. Cool. So it didn't like it because we have to specify columns. And now it probably reads from stdin and can't get anything. So what if we say echo hi ho and then put this into this program? It gives me hi. Now it gives me ho. And now it gives me hi ho foo. Interesting. Nice little program. So let's see how that works. Usage and exit. Let's see. I think we want to get right into hacking it just for the fun of it. So first of all, where's main? Okay, so here it parses the arguments, returning a vector of parsed integers. And I'm going to look at it and see if I see anything that I would do differently. Just for the fun of it. Yeah, I think something we would do right away, which is also something they discuss here in the Reddit thread, is that you should mark stuff as divergent if it is divergent. So if you exit the process, then it's divergent. If you go into an infinite loop, you're divergent. So that helps you with branches or with return statements in general, because then the branch that you have possibly in a match statement will not count towards your desired return value, which is pretty useful actually. So divergent is something you probably want to define if it's the case. So if there's nothing, show the usage, which is pretty short too. And this is something we could actually put to std out, right? So maybe do a write line here. And then we get everything from IO. I think that's something you don't want either. So let's see where it breaks. I guess stdin is used, huh? Yeah. So that's what we use as well. Then we want write. std that's what I want for the output here, because I don't want to write that to std out. Whenever there's some sort of error message that you want to provide, hand it over to std error, which will make using the program a bit easier. Good. Let's see if that still works. Cargo build. That actually works. I am a bit surprised. Lucky us. So, back to business. So you remove the first one because that's the program. And then we iterate each argument. And try to parse it. And that's, can this be made more idiomatic? We convert each argument. If there's something wrong, we exit. And maybe we can do something like unwrap or else or something. And maybe, this column arc, here he knows what kind of vector we want during collection, right? So type inference kind of handles this for us, so we never have to provide a type, which is pretty cool, by the way. So my question is, can we do something like x into? No, wait. Actually, this wouldn't work, I suppose, because into converts directly, it doesn't provide a result type or something. So from string is something you want, or parse. I think parse is, considering we have strings here, what we might be able to do as well. Let's see. And speaking of which, we have no external crates here, yet we pulled in the dependency, so let's remove that right away. And maybe also up the version number a bit, just for the fun. Okay, so from string is not required anymore, still it works. And now we can do something else, right? What about a flat map? Because a flat map will discard values that don't work. So we could use the iteration scheme to just discard stuff that we can't handle. But we want to discard it loudly. I think that's also part of the deal here. Yeah. So I would probably use a match here because that's definitely more idiomatic. So let's match on the return value. If it's an OK val, return the val. Otherwise, we print the usage and exit. And maybe we also want to provide an optional or some kind of error here, huh? Usage and exit. How often do we do this? We only do this here. So I have no idea. And so that's an optional. And currently I have no idea what kind of type it is, so let's wait for the compiler to tell us. Oops. So first of all, let's clean up the syntax. And now this is not required anymore. And stuff doesn't work. That's good. Takes one argument, so we start out with none. And here actually I want to provide the error message. Well, I could convert it into an error message, right? Should I? Yeah, let's convert it into an error message. And then I actually know what's going on here, because then I want to provide a string. So we generate something that is heap allocated. Failed to parse with error. So this is something we probably want to put into parentheses, and now we go like that. Do we have enough space for this? Maybe. So parse does not consume the value. That's good. So we can just drop it here. And then we drop the error, which should implement display of some sort, because if it's a good error. Oh yeah, it's supposed to be an optional. And this is probably the point where we exceed the line length. No, it still works. Nice. Cool. So now we have to use this and say, actually, if we just use one item in this thing, then we use if let, right? So if there is some error message, or let's call it message. Let's call it message here, huh? If there is some message in message, then we print that as well. Maybe we prefix it with a new line. And then we just drop the message here. Like this. And it should actually tell me that we are not using... And why does it not tell me that? It should tell me that we are not using the return value of WriteLine, which is a bit odd. Why does that not happen? Because result is must use and WriteLine returns a result, I thought. That's a bit odd. Yeah, here we indeed don't care, but in the moment we print it for real here, then we do care. Yeah, well, that's interesting. So let's see how that looks like now. Let's run it. Still works, that's good. And now if you give it a foo, fail to parse foo with error invalid digit found in string. See, that's a bit better. Cool. And I like this mapping approach. And probably we can also just return it because the return value is known. And look at that. You don't have to remove it. We can just skip the first one, right? Skip one. Then we iterate it. Then we map it. And at last we collect it. And this is kind of what we want, huh? But skip doesn't work as I think it would work. No method named skip. Oh yeah, sure, we want to iterate that first, huh? And now we don't have to call iter again. And now parse is not what it wants anymore. Why would that be? That's, oh yeah, sure. You want to iterate that again. No, wait. That is weird. Skip should return an iterator. What kind of thing is skip if it doesn't support map, or if map is something different now? Because now my X all of a sudden is not what I think it is. That's interesting. That's unexpected. That's unexpected indeed. So let's try. What is skip doing for us? Creates an iterator that skips the first n element of this iterator and then yields all further elements. Yeah. I thought so, right? But that doesn't work. That is very, very odd. Because, yeah, skip one element, right? This is what we do. But this changes, for some weird reason, the output of my arguments iterator. But maybe now that I changed it a bit, what if I remove this? Does it then work? Sure, we removed this. This worked, right? Aha, so that's not related to the skip at all. I think it's related to this thing. So what do we expect here? Do we expect strings? Or what? Wow. So what kind of... Maybe it doesn't know anymore what I want to parse here. Maybe the type inference inferred that it's unit what I want. Let's have a look at env args. That's interesting. So I tried to just hack it the way I think it should probably work, but it didn't, which is not so surprising, but I was hoping it kind of works for quite a while. Anyway, so that's args, right? And args, that's an iterator over args, and that gives me an optional string. Yeah, fine. So that's standard iterator approach. Yeah, so we get strings here. Fine. And what's the problem with you here? All of a sudden. Oh, damn it. I'm looking at the wrong thing. Ah, the semicolon. Got me. Yeah, so now we can do as we please. Skip one iterator, skip one, and we are done. I was totally misinterpreting what we see here. And yes, that doesn't need to be mutable anymore because we don't remove stuff. All right. And what we could do is we could even prevent that initial collection here. Well, on the other hand, we will always collect. But this way we have two arrays, but we probably only want one anyway. So let's do this instead. I don't think that we need an iterator then. This will return a vector over stuff. That's fine. And let me just put the check here. Is there some function called empty? Let's see. No. It's not. I thought it might be. Maybe it is empty. IO iterator empty. No, is empty. On vec. We have a chance. Let's try. Yeah. So I think that's pretty neat. Easy to read. No abstraction required, like, okay, if length is greater or equals to 0. So if you don't provide anything, then it will tell me that I need to specify columns. And maybe it's even column number, and then it's like that. Oops, we have to specify 1. And then, how do you say it? And then 1 or more, but at least 1, right? So that's kind of the syntax that we would expect here. And yeah, this doesn't happen right now, but maybe it does now. Cool. So that still works. Nice. So I think we improved the parsing quite a bit, I'd hope. And let's keep going. Yeah, the handle input string, that's kind of the important one, huh? So that's also not required. String new is quite self-explanatory. That's our read buff. And here, this entire loop, I don't like it. I think we can also read lines or something, huh? Is there a read lines iterator on buff reader? Or a lines iterator? Let's see. String lines, IO lines, an iterator over the lines of an instance of buff read. So I think we can do this on std.io, because I think std.in implements buff read, right? Because it probably is. Oh, interesting. It doesn't implement buff read, but we could wrap it. Do we gain anything? We just gain. Yeah, we could probably just go ahead with read line. Yeah, probably. I would prefer to have some sort of while let sum. So this handles the error case, some line, but it doesn't handle when we are done. It's more idiomatic though. So now we get a line. It's more like line info. Actually, it's bytes read, right? Read line. Yeah, I think it returns the amount of bytes read. I'm not sure if it's bytes read or characters read. Oops, that was the wrong one. N is the number of bytes which we write. Anyway, if that's 0, then we are at the end of the file. That's what I got so far. So we read that bytes read. Yeah, unfortunately, I don't know if I can while let. Can I do this and bytes read greater 0? I don't think so. So the rest of the stuff, line val. Okay, whatever this is, we will have a look at it. Let's see how far we get. So line we don't have, bytes read probably we cannot use here, huh? Unresolved name, bytes read. Nope, we cannot. That's very unfortunate. But I guess we can just have another if clause here and break if it's equal to 0. So that's an EOF. And usually I would put more comments in here, but I will just follow the coding style in every which way and say, and obey a no comments policy. So here we go. So that should give us what we need semantically. It should still work as before. If it compiles. Unresolved name, line 46. Yeah, and this stuff we can leave out as well. The clearance we have to do though, even though we really will have to look at how this works. Okay, so expected a result. Oh yeah, that's not an optional here. It's an okay. Bytes read. And errors we just discard. This is exactly the same semantics as were used previously because errors were not returned, which is something I don't really like in a way, considering, I would like to handle errors because we are in Rust and Rust is safe. So let's do that real quick. I think under these circumstances, we better loop here. And then, yeah, this will be the most important line for us. Let's loop. We could, I think we have to match. I was thinking we could try on this. Error handling could be done here. Here we could put an IO error, which is what this thing returns, right? It's an IO error exactly. So let's do this. Let's do it that way. Let's put all the logic here. So this will now return an IO error. And here we'll do some more error handling, I think. So let's return the error. If there is let's return an IO result. Because that's what matters. No, wait. Damn it. Yeah, I can also bail out right away if there's an error. I could bail out from here. Good question. You know, we could have a result type here that returns an IO error, and if everything is good, or an let's put a result here. We will just have a nonsense OK here, and this, and now we can try to match on that. And if there is an error, then we just return it. This basically allows us to try on that, right? So let bytes red be this. That is nice. And the result will be given here. And if there is nothing more to do, then we will also return with an OK, because that's exactly what would happen here. Like this. And now we can handle the value. Good. And here we now would want to print something. So if let err, if there's some error here in handle input, then we shall write something about it. We write to std err and then say error when reading from std in, which shall be this one here. We just print the error. And also we exit with non-zero, right? Exit 1, for instance, like that. Good. Process exit, there we go. I think that's kind of the semantics you want to have. This is success, fine, and this should still work. It does. That also works. Good. And yeah, I don't know how to simulate a broken std in. Std in would have to close on that one. But anyway, you will handle this now, that's for sure. Good. And now the next thing. Why the clone stuff? Split white space. Is this clone still needed? Because that's a reference, right? I don't think that's needed. Read buff. So now the problem is that there's still a borrow of this out here. So probably we want to put this into its own scope so that it will be gone when we try to clear on this one. See, it actually works. Did you mean run? I did. 1, 3, no. Like that, cool. So I think we made this much more efficient because we just use one buffer. The problem is still that we need UTF-8 compatible input, but that's something I'm not going to change right now. So here, the handle line. Handle line does what? Handle line prints things. That's fine in this context, I think. So we basically verify that we are that we are within the range of the vector, but can we do it more? Do we have something that lets the vector check for us and maybe return an optional? So do we have get? We do, because that's exactly what we want, right? We just want to get on this stuff. And if let some val in column vals get, and now we provide it with column num -1 because we are 1 based in the input, which is not really coming out that well. Interesting. Look at that. What happens if we provide a 0 here? Yeah, I thought so. Yeah. And where does it happen, the arithmetic overflow? So that's something we want to protect against, right? And what happens at -0? Same thing, huh? Oh, that's a flag now. Oh, damn it. invalid digit. Okay, that's good. But 0 is still a problem. So probably you wanna parse not into usize, or we want to do this differently. Here we want to parse into usize and then check again. So this one shall be an isize instead, so we can parse these things. And then we verify if it's a val, if val smaller than 1, then we shall also say something about it. I think that's more like it. So column numbers must not be smaller than 1. Must be larger 1. Maybe that is what we want here. And yeah, I don't need to print anything really. Okay, so now I don't need a format anymore. Now I just need yeah, fine. I will give it the string then. It's okay. Who cares? We are now unnecessarily locating memory. That's what I'm thinking, but it's an error case anyway. ToOwned. Even though in this context, maybe toString. I don't know what's better. ToOwned, toString is both somewhat abstract because people could say, well, toString, it's a string already, right? Well, technically it's a string slice. ToOwned, well, don't we own it already? Actually, we don't. Yeah, so toString. I convinced myself with my spurious comment. So if this is not the right thing, and here we do as usize. And this will provide us with the right thing. I think this will now possibly be better. 56. Oh yeah, we actually didn't finish this. Some val. That should work. And really, I wonder, I mean, for print it's okay, but why don't we have to do anything with the return value of right line? I don't get it. Rust-C version is, oh, we are nightly here? You gotta be kidding me. That's weird. So column numbers must be larger 1. Good. Now we handle this correctly. Nice. Much better. And yeah, that is, I think that is that. Something I dislike is that it puts spaces here. Maybe we should only put a space if we are not the last one, huh? So how do we do it? Suffix. Let's have a suffix. That is a string slice. And yeah, we start out, and we would probably want to enumerate this then, or somehow check if this is the last thing. I don't know if there's some great way to figure that one out, except for comparing numbers here. Also, we don't know if the column numbers are correct in our context. Yeah, we don't know, right? Actually, we do know. We know if we are the last thing that is printed because we are out of column numbers. But we could also be the last thing that is printed because the following column numbers are invalid for that line. So yeah, it's kind of difficult to do this right. I don't know. Actually, I don't know how to do this better. So let's keep it that way. And at the end, we print a line. Well, fine. Okay. I think I'm good for now. So let's prepare a commit here. Or let's prepare a feature a pull request real quick. Git remote add mine git commit. Well, actually, I think I can use this guy. Yeah. Performance enhancements and more. I'm always forgetting this. Oops. Idiomatic Rust. I think that's primarily it. Oh, I didn't save that one. For good reason. Are we good? We're good. Good. Push mine. And I think in a moment we are done with this let's look at, which got a bit of a hack as well. But I think let's look at with a bit of hacking are a cool thing to do. So, able to merge. Let's see. Lots of changes. Yeah, let's do it. It was just some fun for me. Please have a look and feel free to merge if you like it. Cheers. That is that. That shall be my start in the day, 40 minutes. Thanks for watching and have a great day.